Okay, so we're going to solve this problem where we're finding a volume of a solid using slices. So our question says, find the volume of the solid that lies between planes perpendicular to the x-axis at x equals 0 and x equals 4. The cross sections perpendicular to the x-axis are squares whose bases run from the x-axis to the parabola y equals x squared minus 4x. So what we're saying is we want the solid that goes between x equals 0 and x equals 4. That's what the first sentence says. And the cross section, these squares, let me do this so I can turn a little bit. We can see if we slice them this way, we get these squares. Okay, see that's red squares 1. I can move. We can see all the way through. We get these nice squares. And the base of the square goes between the x-axis and this parabola, which we can see the zeros are 0 and 4. So that gives us this parabola x squared minus 4x. Okay, now our formula for these type of integrals is to go between our starting point 0 up to 4, and then it's a of x, where a is the area of each cross section. Well, we have a square, and we know the area of a square is the side squared. So the side times the side. Now, we need a formula for the side of this square. Well, any x value, as we move, we know the base changes with the parabola. So it's at its biggest point where we have the vertex of the parabola, and they get smaller as we go down. So the side, the length of the side, is actually equal to the height of the parabola, which we have our formula, x squared minus 4x. So the area here is that side, x squared minus 4x squared. So we're going to want, I want to make this a little thicker, we're going to want the integral from 0 to 4 of x squared minus 4x squared dx. So what we're really doing is we're adding up these really thin rectangular prisms from 0 to 4, where this gives you the side of the square. Now this is a pretty easy integral. So if you were going to do it by hand, you would first square out x squared minus 4x. And that would give you x to the 4th minus 8x cubed plus 16x squared. And then you would use the antiderivative rules, add 1 to the power, divide by the new power. Or if you put this in your calculator, you'll see that this gives you 34.13, and the 3's repeating, which as a fraction is 512 over 15. So the setup is the most important part and the most difficult part. One reminder for other problems is that this area really comes from whatever shape these cross sections are. So if they were a triangle, you would use the formula for a triangle. If it was a circle, it would be a circle. So here, the reason we used the s squared was because these cross sections were squares.